Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So we move to the problem for today. That is basically this. So we have two positive integers, n and k. The expansion of x1 plus x2 plus all the way up to plus xk whole to the power n is given as a summation of some these terms. So these are the general terms of this expression, basically given as. So here's this what we call something as a multinomial n factorial divided by n1 factorial into n2 factorial or that will nk factorial and multiplied with x1 to the power n1, x2 to the power n2 or that will xk to the power nk. So the catch is where the sum is taken over all non-negative integers n1 to nk such that the sum of these non-negative integers is n. So we have to basically compute what's the coefficient of x to the power 5 in the expansion of this. So kind of we understand that this expression that we have is the general expression in this expansion. This is very similar, like, and so if you can see that if we restrict the number of terms to 2, that is if k is equal to 2, then this turns out to nothing but the binomial expansion. And in general case, it's actually called the multinomial expansion. So this is something that's very useful to know.
To book a trial class for your preparation courses of IIT JAM MS, ISIM Stat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So going along, we need to see that for this specific expression that we have, what the general term looks like. So first note that the power n, it goes to numerator like it always does. So it's 4 here, so it's 4 factorial divided by some a factorial, b factorial, c factorial, which are all non-negative integers that we have seen. They should add up to 4, and each of the terms will be raised to power a, power b, and power c. So we have 1 to the power a, which is okay, nothing. 3x whole to the power b and 2x square whole to the power c. Let's simplify this to get 4. This part remains same. We bring 3 out and we bring 2 out to get 3 to the power b and 2 to the power c, and we get x to the power basically b plus 2c. And we have that a plus b plus c is equal to 4. So now since we are trying to find the coefficient of x to the power 5, we know that this thing must be 5. So that's where we have this first equation, b plus 2 is equal to 5. And we know that the sum of the non-negative these integers must be 4. So we have the second equation here. So we have two equations in 3 variables. Common sense is that probably we won't be able to find, like, we won't be able to employ our normal techniques like simultaneous linear equations, like elimination or something like that, elimination and substitution. So in this case, we have to employ kind of some like a hit and trial method and some inspection. So the first tool that we're going to use in our inspection is basically note that they are all non-negative integers. So since they're non-negative integers, there's some nifty thing that we can derive from here after this relation. So since they're non-negative, a, b, and c are all greater than or equal to 0. But can they be greater than 4? No, right? Like the maximum there can be is 4 in the case that the others are 0. So they're also bounded above by 4. So this gives us like a possible range of values that these 3 can take, which greatly reduces our searching space. So let's just get some relations out of the way. So subtracting 1 from 2, we get that c minus a is equal to 1, which is a very useful relation that we'll be using. So let's mark this as 3 actually. Now come back to this first equation, b plus 2c equal to 5. 2c is always even because 2 is multiplied with it. So b, since sum of b and 2c is 5, which is odd, b has to be odd because the sum of two evens will be even, when 5 is not even. So b has to be odd. So b has to be an odd number between 0 and 4. So how many odd numbers are between 0 and 4? 1 and 3 itself. So there we can see, like, we are exploiting this fact that the non-negative integers are bounded below by 0 and above by 4 to get a very reduced searching space for both the values. Initially, we know that we can take any value between 0 to 4. Now we know for sure that we can take only these two values, 1 and 3. So let's just put 1 and see what happens. So we're putting b equal to 1 in this equation, in equation 1. You can see that 2c is equal to 4 and we get c is equal to 2. Trying equation 3 here, this one c minus a is equal to 1, we can get a is equal to 1. So one of the solutions is 1, 1, 2. And the next one, when we put b is equal to 3, we get 2c is equal to 2, which is basically c is equal to 1, and then we can get a is equal to 0. It's not negative, so it's allowed. So another solution is 0, 3, 1. So note that we have got three solutions of a, b, c, which satisfy both these equations. Now we wanted to find the coefficient of x to the power 5, right? So general term that contains x to the power 5 is basically this thing when you substitute the three a, b, c tuples in this. So what is the final coefficient? Since there will be basically two terms with something x to the power 5 plus something x to the power 5, the final coefficient will basically be the sum. So in this general term, we have to basically substitute these two values and then you have to take the sum. So which is this, and it turns out to be 360, which is simple calculation. So a key takeaway from this would be noting what the general expression is, like general term is, and then using the known assumptions, especially in these cases where they're integers, and using the fact that they're integers to this extent is important in this case of problems. So that would be all for today, and I'll see you in the video. Thank you.